we're going to take a look at the solving of inequalities in two variables. And when you have two variables, x and y, for example, as in this inequality, solving and graphing are actually one and the same. So we just want to go back to the idea of what a one variable inequality looks like, and that would be something like x is less than -5. And if we were to look at the equation x is equal to -5 and graph that on the number line, we've got a number line here, the point at -5, and for the case x is equal to -5, I would shade in a point, but because I have this inequality where there's no equal sign there, I'm actually going to leave that as an open circle to indicate that would be the point. And then the inequality less than -5 would be shaded to the left. So you can see that the solution of an inequality in one variable is going to be the shaded portion of a number line, and it either will include that endpoint or not include it. For two variable inequalities, the solution is actually going to be the shaded portion of a plane. Just as x equals -5 is a single point, if we have an equation such as 3x plus 5y is equal to 15, that would not be a single point, but it would be a line. So we're going to use this procedure to give the solution. So the first thing says graph the inequality as if it were an equation using either solid or dotted lines. So I'm going to first imagine the equation 3x plus 5y is equal to 15. And the way that I would graph this, because it's not in slope-intercept form, I would plot the intercepts. Those are probably the two easiest points. When I let x equal 0, I get 5y is equal to 15. And that gives us then that y is equal to 3. When I plot the other intercept, I let y equal 0. When I let y equal 0, I get 3x is equal to positive 15. And that gives me that then x is equal to 5. So I have the points 0, 3, and also 5, 0. And now before I connect the dots, I want to be aware of this instruction here. It says use a solid line for greater than or equal to or less than or equal to. So that equal to would indicate that we're going to make this line solid, showing that that line would be included. But it says use a dotted line for strictly greater than or strictly less than. And in my original inequality, I have a strictly greater than. So I will use a dotted line here. Next, it says decide where to shade using a test point. So I can imagine any point that's on either side of this line, but I want to choose a point that's easy to use. And when I look at the origin is squarely on the lower side of this line, so that's a good point to choose. If the origin had actually been on the line itself, I wouldn't have wanted to pick it, but again, it is below the line. So I am going to test the origin. I'm going to test 0, 0 in the original inequality. So plugging that into the inequality, I have 3 times 0 plus 5 times 0. And I'm going to ask myself, is that truly greater than 15 or not? And the answer is no, that is not a true inequality. And so this is false. And what that means is that the point 0, 0 is a false point. So I should not be shading on the same side as 0, 0, but instead I should be shading on the opposite side as the origin. And that opposite side to the origin will be the true side. So we shade on the true side and we leave the false side unshaded. If I had chosen any other point on the lower end, on the lower side of this line, it also would have given a false result. And if I had chosen any point on the upper side, that should give me a true result. So for example, let's just test something else to see if this really is right. Let's test the point 0, 6 and see, is the point 0, 6 in the true region as we are expecting? So when I let x equal 0, in the original inequality, 3 times 0 plus the y value, 5 times 6. And is that greater than 15? And the answer is yes. 5 times 6 is 30, which is greater than 15, so that's true. And the point 0.06, which is up here, is in the true region, and it's on the shaded side as we expected. Next, let's take a look at a system of two linear inequalities. So for the two inequalities, it's not really much different than a single inequality. We'll just do the same procedure twice. So we're going to take a look at the first inequality, y is less than 3x, and we can graph it as if it were a line. So if we look at the line y is equal to 3x, that's a line going through the origin with a slope of 3, so we're going to anchor here, and again it's got a slope of 3, so we go up 3 units for every 1 over. And we can continue this. And again, before we connect the dots, we want to determine whether this should be a solid line or a dotted line. And because it's a strictly less than, we are going to make this a dotted line. Next, we're going to decide where to shade. And because this line goes through the origin, choosing the origin as a test point is a bad idea because it won't tell us whether we are squarely on one side or the other, true or false. So I want to choose a point which is clearly on one side or the other, that's easy to use, and this one looks good to me, the point 30. So I'm going to choose that as my test point. So when I test the point 30, I'll plug it into the original inequality. So I have y is less than 3x, so y is 0, and less than 3 times x, which is 3. And we can see this is 9, and 0 is clearly less than 9. So this point at 30 is true. So I know that this is true, and that means that everything on the same side, on the right-hand side, will also be true. So I can shade this entire area. Next, I'm going to move to the second inequality, which I'll write as an equation. So we've got y, and now instead of greater than or equal to, I'll just write it as equal to negative 3x plus 6. So when I graph this line, I have a y-intercept at positive 6, and the slope is negative 3, so I'll go down 3 for every one to the right, and I can plot those points, but I also want to decide whether when I draw the line, whether this should be solid or dotted. And because there's an equal to, it's a greater than or equal to, we will be making this a solid line. Solid line again means that the points on that line are actually included. Now when I want to decide where to shade, I can test a point which is on either side of the line, and this time the origin in relation to the pink line is clearly on the left side. So I will choose the origin as my test point. And when I plug in the point 0, 0 to the original inequality, y is equal to 0, and I'm going to test whether that's greater than or equal to negative 3 times 0 plus 6. And you can see this term drops out, but 0 is not greater than or equal to 6, and so this point is false in relation to the pink line again. So what that means is that on this side where the origin is on the left, that's the false side, and I will not shade it, but I will shade on the opposite side, which is the true side. So when I shade over here, you can see that there is a region of overlap. So there's a region down here which is blue but not pink, and then there's a region up here which is pink but not blue. And then there's a totally unshaded region, but the double shaded region is the region of the solution, and that is my solution. The graph here that shows the double shade is the solution. One thing to note is that the pink line is solid, so that means all the points on that line are included. The blue line is dotted, so the points on that line are not included. The last thing that I want to point out to you is that there is an alternate way to shade that doesn't use test points. And there's an important condition, and that is that y is isolated on the left. And this happens fairly frequently when we have equations in slope-intercept form. If y is isolated on the left, remember y means the vertical dimension, and if the vertical dimension is less than something, vertical less than something means below. And so what we see here is that if we've got greater than or equal to, we're told to shade above, but if we've got less than or equal to, we shade below. So for my first inequality where y is less than 3x, I've got a less than symbol. That means shade below, and on the blue line you can see here the shaded region is below this dotted line. However, for the second inequality we have y is greater than or equal to, and so this greater than means above in the vertical dimension, and shading above this line we are shading above and also to the right. And so if we had used this method to decide where to shade, we would have gotten the same answer as we got over here by using test points. And which method you use is up to you. Once we've graphed a system of 2 inequalities, there's nothing to stop us from graphing a system of 3 or even 4 inequalities, except the number of colors that we have. So let's take a look at this system over here. So we have 3 inequalities, and let's graph the first inequality as if it were an equation. So we're looking at y is equal to -1, and this is a special equation. It's a horizontal line, and it has its y-intercept at -1. So we can draw that horizontal line through the point at -1, and I've drawn the line as a dotted line because the inequality is strictly greater than. I also want to decide where to shade, and because the y is isolated on the left, we can use the alternate method of shading. Greater than means shade above the line, so we'll do that. And that gives the solution to my first inequality. Next, let's take a look at the second inequality, which I'll write as the equation 2x plus y is equal to, now instead of less than, I'll make it equal to 4. And that gives me the equation of a line. So I can decide how to graph that line by plotting points. And I think that I will choose the intercepts. So when I let x equal 0, I get 0 plus y is equal to 4. And that means that y is equal to 4. And when I let y equal 0, I get 2x plus 0 is equal to 4. And dividing by 2, I get that x is equal to 2. So I have the points 0, 4, and also 2, 0. And I need to decide whether this will be solid or dotted. And it does look like we've got a strict less than, so this will be a dotted line. And now I need to decide where to shade. And since the inequality is not in slope-intercept form, it doesn't have the y isolated on the left, I'm going to use a test point. When I look at the origin in relation to the blue line, the origin is not on the line, it's clearly on the left of the line, so I can test that point. So when we plug the point 0, 0 into the original inequality, we get 2 times 0 plus 0. And is that less than 4? And the answer is yes, 0 is less than 4. So this is true. And that means that the origin is on the true side, so we will be shading on the same side as the origin. Okay. And that's the solution in relation to the second inequality. Now, if we had only 2 inequalities, we would be done. We would say that the overlapping region, which has both pink and blue, is the solution. However, we do have a third inequality to account for, so we will graph that. Now we'll look at the third inequality. X is greater than -2 as if it were an equation. X is equal to -2. And this one is a vertical line that passes through the point where x is equal to -2. So when x is -2 and y is 0, we have a point here. and the vertical line that passes through that. And we're going to make it a dotted line because it's strictly greater than. So that will be the third line. And now we want to shade in relation to that. And just as we said y greater than something, y being the vertical dimension and greater than mean going up. When we have x greater than something, x greater than, we usually shade going to the right, and so we can do that as well. If you're not comfortable with the idea of using the inequality symbol with the isolated x, you can always go back to the original idea of a test point and test out something there. And now we've got a lot of colors, a lot of things going on here, but what we need to do is look at the region that is triple shaded, that is including all three, the blue, the pink, and the green. And that's going to be this triangle here, so I think I'll shade it more heavily. And I'm going to use yellow so that I don't write over the dotted lines and solid lines on the edges of this shape. But again, it's a triangle, and it's bounded on the left by the green, it's bounded on the bottom by the blue here, and it's bounded on that right diagonal by the pink. So this is going to be the solution area of this system of three inequalities. And again, you can have all kinds of shapes. You could have a four-sided or five-sided shape, but I think we'll stop at this point.